So Maxwell in the 18th century, has developed these equations. Now listen, now stop writing of the test and listen carefully here. Which we find difficult even today to understand. Maxwell in 18th century developed these equations. That time there was very much less exposure to information was there, but still he could develop, which are yet regarded as what we can say prime things in electromagnetic theory. So today I will just introduce, and in the tutorial slot and in your free time and the weekend till tomorrow, one thing is that you will not search Google. You will not search Google, and I am sure that you have not searched. So you can tell others that your contribution is very much equal to Maxwell. That the equations are developed by you. Equations are developed by you. So what now? Think, if we are to be very much broad, without giving any hint, that much time we don't have because it's not beginning of the semester. Otherwise, that would have also been possible. So what different things we have now, you are well aware of. Number one, rho. Q I will not say. Q is a undefined thing now. With the things cleared to a large extent, Q as a point charge is undefined, but there can be Q over a volume. So rho V, and in that context Q is known to you. Then I is known, Z is known, voltage V is known, electric field E is known, electric flux density D is known, magnetic field H is known, magnetic flux density B is known, then electric flux and magnetic flux we use it as phi and psi. That is, there is no universal convention, but that is, we say flux over area. So these things are known, and what we need some kind of relationship between these terms, their differentials. Between these terms and their differentials. So if this very broad level question is asked, then there may be huge churning required, what kind of relationship we can have. But I will give a hint in the sense, not hint actually, I will restrict the focus of thinking, that what you are supposed to work on. One simple thing, what we will do is, del is there, a cross product with something and a dot product with something. So del, again del dot D, wherever D is there you can also have E, only epsilon will come, but we use Maxwell's form. So del dot D is one of Maxwell's equation, del dot B is another equation, then del cross H and del cross B. Why H and why not B? If B is there, only B will come, not any other difference. So these are the left hand sides of four Maxwell's equations. These are left hand sides of four Maxwell's equations. What would be the right hand sides that we have to identify? So these are simple, these are somewhat difficult. So you should proceed in the sequence 1, then 2, then 3, and then 4. Now I will give the rules on which it is based. It is based on Gauss law. Based on Gauss law. This is based on Ampere's law. This is based on Faraday's law. And this is not based on anything as such. It is an obvious corollary. It means there is nothing new there. So this is what kind of learning is expected, and what the things are there to be used. One is time differential of, okay, त्यात मला मी काय काय येणार आहे पण सांगतो. म्हणजे क्वेश्चन्स काय, del dot d equal to what, del dot b equal to what, del dot e, del cross e equal to what, del cross h equal to what. आता इथं काय काय येऊ शकेल, उरले टर्म्स येऊ शकतील. हे तर चार एकच पाहिजे तर लागले तर, म्हणजे आता मी घेताना काय घेतो, d घेतलं तर e घेत नाही, b घेतलं तर h घेत नाही, d घेतो इकडं, b घेतो, दोन झाले, हो एक आहे, c चार, आणि बऱ्यापैकी तुम्हाला मी हिंट दिली. पण आता त्यामध्ये they can be rho म्हणजे rho v unless otherwise specified, rho is rho v. These and also their time differentials. अशाच लक्षात आहे का, उजव्या साईडला काय काय येऊ शकतं, हे टर्म्स येऊ शकतात, किंवा ते टर्म त्याचे कॉम्बिनेशन डॅबा d बाय डॅबा t, डॅबा b बाय डॅबा t, डॅबा rho v बाय डॅबा t, आणि डॅबा जे बाय डॅबा टी येत नाही. म्हणजे पुन्हा त्या उगीच अवघड करायला हे टर्म्स आहे. लक्षात आलं का, म्हणजे आता काय जोड्या जुळवासारखं आहे, पण थेट करेक्ट कुठलं दिलेलं नाही आहे. म्हणजे थेट मॅच द पेअर्स लेफ्ट हँड साईड दिली आहे, राईट हँड साईडला कशा कशाचं कॉम्बिनेशन होऊ शकते ते दिलंय, त्याच्यावर विचार करायचा आपल्याला. सो दिस इज व्हॉट वी कॅन से लर्निंग. आता कसा विचार करत जायचं, तर एक सगळ्यात सोपं इमिजिएट इन्स्टंट आन्सर पाठ असेल तर होऊ शकतं. म्हणजे आपण ब्लूम्स टॅक्सॉनॉमी मध्ये रिमेंबरिंग म्हणतो, ऑलरेडी शिकलेलो आहे आपण. कुठलं, डेल डॉट डी इक्वल टू रो व्ही. म्हणजे ते ऍक्च्युली ते मॅक्सवेलचे चार पैकी पण अगदी सोपं आहे. म्हणजे ते काय फक्त जे ऑलरेडी शिकले, म्हणजे बऱ्याचदा असं होतं की तुम्ही बघितलं असेल सिलेबस रिव्हिजन मध्ये कधी कधी काय होतं, जुना विषय असतो नाव बदलतं. तर तशा टाईपमध्ये डेल डॉट डी इक्वल टू आपण गॉसला शिकलो होतो. तर गॉस लॉ ऍक्च्युली म्हणजे गॉस लॉ असा होता, दी इलेक्ट्रिक फ्लक्स over a closed surface equal to charge enclosed, and when it comes to point form it becomes Maxwell's equation. So one very simple Maxwell equation which doesn't require much discussion, which is very simple, that del dot d is equal to rho v. I think we should not spend much time on it. Now can you by common sense, आता इथे तुम्ही हे काही बघितलं नसेल असं अपेक्षा करूया आपण, किंवा सिलेबस मागच्या टेस्टच्या वेळी ओल्ड पेपरमध्ये होतं म्हणून तुम्ही बघितले असं असेल तर प्रश्न नाही. कॉमन म्हणजे बघितलं असेल तर मग ते काय उत्तर तुम्ही देणारच, सोपं आहे ते. आधी बघितलं असेल तर ते मेमरी टेस्ट झाली असेल, पण नसेल बघितलं तर कॉमन सेन्स वापरून इलेक्ट्रिक मॅग्नेटिक मधली काही इक्विव्हॅलन्स आणि काही डिफरन्सेस लक्षात घेऊन डेल डॉट बी काय येईल, जास्त हे करायचं नाही, अगदी कॉमन सेन्स लावायचा. काय येईल, डेल डॉट बी हे काय आहे, इथं रो आहे. व्हॉट इज रो, इलेक्ट्रिक चार्ज डेन्सिटी. तसं मॅग्नेटिक चार्ज आहे का, नाही आहे. There is no concept of separate magnetic charge. In that case काय होईल, इन दॅट केस काय होईल? डेल डॉट बी काय असेल? डेल डॉट बी, आता मी उत्तर देतो, आता तुम्ही डायरेक्टेड थिंकिंग करा. डेल डॉट बी 0 आहे का असेल, कसं असेल थोडा विचार नंतर. डेल डॉट बी 0. आता डेल क्रॉस एच काय आहे? डेल क्रॉस एच तर थोडं तुम्ही शिकलाय. डेल क्रॉस एच इक्वल टू जे तुम्ही आता म्हणतो, पण ते इनकम्प्लीट आहे. इनकम्प्लीट. डेल क्रॉस जे एम्पियर्स लॉ साधारणतः बऱ्यापैकी पण तिकडे चालू होतो. स्टोक्स थिअरम, एम्पियर म्हणजे गॉस लॉयड पॉइंट फॉर्म म्हणजे मॅक्सवेल्स इक्वेशन डेल डॉट डी इक्वल टू रो. तसं एम्पियर्स लॉयड पॉइंट फॉर्म म्हणजे डेल क्रॉस एच इक्वल टू जे, पण ते म्हणजे डेल क्रॉस एच इक्वल टू जे हे बरोबर का चूक आहे हा प्रश्न अपूर्ण आहे. म्हणजे काही काही ठिकाणी डेल क्रॉस एच इक्वल टू जे येतं, परंतु त्याच्यामध्ये आता एखाद्या पॉइंटचे कोऑर्डिनेट्स दिले आपण 3, 4, कोऑर्डिनेट्स ऑफ पॉइंट 3, 4, हे आन्सर एका दृष्टीने बरोबर आहे, पण ते अपूर्ण आहे. म्हणजे जर आपण एक्स वाय प्लेन मध्ये आहोत ते गृहीत धरलं असेल, आधी सांगितलं असेल, तर पॉइंट 3, 4 म्हणजे 3, 4, 0, अदरवाइज इट इज इनकम्प्लीट. तसं एका स्पेसिफिक सिच्युएशन मध्ये डेल क्रॉस जे बरोबर आहे, ते डेल क्रॉस इक्वल जे बरोबर आहे, पण ते पूर्ण नाही आहे. इट इज ऍक्च्युअली जे प्लस समथिंग, आणि ते समथिंग नसेल, ते समथिंग 0 असेल. ते समथिंग 0 असेल तर डेल क्रॉस इक्वल टू जे. आता तुम्हाला आय विल गिव्ह यू सर्किट थिअरी मध्ये वेगळे कॉन्टेक्स्ट मध्ये सांगितलं होतं. नाव आहे विल टेल इन डिफरंट कॉन्टेक्स्ट. I will write a question. It is a very significant theme which I am trying my level best to explain. For the absent students, the best what can be the best exercise for absent students? To watch the videos and submit the notes rather than some test. Current doesn't flow through capacitor, but it is as good as flowing through capacitor. Means what? When there is a vacuum, if dielectric is there, then in that case you may not believe to that extent. You may doubt something is happening there. But capacitor provides a capacitance effect even if the dielectric is vacuum, so nothing is there. The extreme case of something is this anti-electromagnetics looking something mystery is this something happening to vacuum. So when you put a capacitor and now we put DC, but after some time it saturates, so no current is there. David, I think last time based on Faraday's law, one question was asked to you, electromagnetic generation, which you have not answered, that I will answer at the end of the lecture. So this was recollected by me when I saw this source again. If a sinusoidally changing, that is AC voltage source, is connected to a capacitor, what happens? There may be resistor, there may not be resistor, even if there is no resistor because of wire some resistance is there, or एकदम आपला काहीतरी डायरेक्ट कॅपॅसिटर जोडला असं काहीतरी ऑड वाटू नये म्हणून आपण फॉर द सेक ऑफ आवर सॅटिस्फॅक्शन म्हणजे दिस विदाउट रेजिस्टन्स ऑल्सो दिस सर्किट वाज कंप्लीट, But to make it more complete, it doesn't make any harm. So we put a resistor. So when alternating source is connected, it is the potential, when it is positive, it is attracting electrons. And when it goes negative, it is forcing away electrons. Or if you think of current, it is pushing current when it is positive, it is drawing current to it when it is negative. If we only think what you are doing, there are some animations there. If we think of movement of electrons now, means suppose that I normally say that if there is something like what we can say angiography, where some dye is put, like that, if I have got some colored dye which I insert by injection here, few electrons are made colored. If few colored electrons, if few or only one, I can say, if only one colored electron is made, how that colored electron will move? If one colored electron is put somehow with a colored dye injection, I made one electron color. What it will do? It will move. When it is positive, it will move towards this. When it is negative, so electron will oscillate. Are you getting me? Electron will have a movement from here to here, here to here. Right? The frequency will depend upon frequency of this. Amplitude will depend upon various factors: resistance, capacitance, and frequency, and its amplitude. Listen very carefully. Frequency will depend only upon this frequency. Are you getting me? That imagination kara pahiye. A single electron is made color. How will you see? Or I think you can do an animation. That electron, that color electron is moving like this. Its frequency is equal to this frequency. Its amplitude depends on resistance, capacitance, amplitude of this voltage source, and frequency of this voltage source. That's very important. In which range it oscillates. Right. So, if I put a section, then I will find that like this, and when one electron is there, when I see one electron, we can consider that it is like a train, one bogie in the train. Above that there are many bogies, behind that there are many bogies. So when that electron is oscillating, every train is moving. So if I take a cross section, I find that charges are moving to and fro. There is a concept of current. So, but what is happening here now? The charges are terminating here. Listen very carefully. Charges are terminating here. They don't, if it is DC, it gets accumulated throughout, continuously. If it is AC, sometime it gets accumulated, sometime it gets diluted. Laksha laga? AC mein what are you doing? You are showing how the electron is terminating there. The electron, since it is continuously, when it is positive, when it is negative, it is drifting electrons away. So electrons are drifted away and they get accumulated here. From here there is no further drift. What are you doing? From here there is no further drift. So whatever drifting gets, so this is like a shock absorber, we can say. What shock absorber does? What shock absorber does? It stops movement, but it can't be abruptly stopped. It stops movement, but it captures it in the form of some elastic deformation, and later on it is again reverting. Are you getting me? So like electrons get drifted away for some time, making this plate negatively charged. At the same time, from the other end, this is negative, this is positive. As it is positive, electrons are, so when it is negative, electrons are put here for you. You mean this is negative and this is positive. It is putting, so it is getting negative charge. There is getting pulled from it is getting positive charge. So the net effect of electrons being pushed by one end of the supply and pulled by other end of the supply during a time when the supply is positive and negative as shown, it gives rise to a similar charge on this side. And when supply reverses, it also reverses. So everywhere when you put ammeter, it will show some current. Actually, how that current is to be measured with AC current measuring, AC ammeter is put, then it gives you average. Instantaneous AC average current is to be perceived, it's not so easy to understand. So AC current जास्त आहे म्हणजे काय instantaneous? Instant AC current जास्त आहे म्हणजे काय? Electron is moving rapidly. Frequency same आहे, पण रॅपिड आणि हे कसं होऊ शकतं? तो वेगाने पुढे तो वेगाने मागे येतो. म्हणजे फ्रिक्वेन्सी तीच ठेवायची आहे, तर जास्त पुढे जातो आणि तिथून मागे येतो, त्याला पण जास्त वेळ लागतो. आणि त्याच फ्रिक्वेन्सीला कमी अंतर कव्हर काय असेल तर काय करणार, तो हळू पुढे जाणार, हळू मागे येणार. म्हणजे फ्रिक्वेन्सी म्हणजे जो असा एक डाय टाकला इलेक्ट्रॉन जो आहे तो फ्रिक्वेन्सी आहे, म्हणजे त्याच तो पुढं मागं आणि पुन्हा त्या पॉइंटला यायची, त्या पॉइंट पासून निघून पुन्हा त्या पॉइंटला यायला वेळ तोच लागणार. मग स्पीड कधी येणार जास्त, त्याच फ्रिक्वेन्सी वेगवेगळे स्पीड असू शकतात, अंतर किती आहे त्याच्यावर. इन्स्टंटेनियस करंट हा कशावर अवलंबून आहे, दिलेल्या टाइम मध्ये किती चार्ज पास होतो. सो अल्टिमेटली देयर विल बी चार्ज मूविंग चार्ज. So movement gets accumulated, stopped here. The plate stops the movement, but the other plates is having complementary movement such that effectively you can see that suppose if when you put an ammeter, what the ammeter will show, whether the ammeter will show something. Ammeter will not show, because what will happen, will the ammeter show something? Ammeter is having infinite resistance. So ammeter or zero resistance. Ammeter zero resistance. So if you put an ammeter, can ammeter be put? असं इथं टाकता येतो का ammeter? Can you put an ammeter here? It will be short. So you can't put the ammeter that actual ammeter that way. It will make a short. So means ammeter can't be put. But what is the current actually? Is there a current flowing? No. So what I can say that current is not flowing, but current seems to be flowing. I mean, listen very carefully. What I said? Ask her. What was my last word, last sentence? Current is not flowing, but current seems to be flowing. How? So, what name is to be given to this current? That name is displacement current. Means, whatever is here, this is displacing it to the other end. So, a current which is not actual current, but it is as good as a current, that is called as displacement current. What is the displacement current now here? What that would be? It would be dq by dt. by dt. Now I am just not exactly scientifically matching the terms, but broadly bringing you to the definition. So Q, what is capacitance? Q equal to CV. Q equal to CV. What is C? Epsilon A by D. अगदी हे नॉन सायंटिफिक मॅचिंग dq by dt म्हणजे dcv by dt. C म्हणजे काय? d epsilon a v by dt प्लस d देतो. v by d काय आहे? v by d so e by d is e. epsilon e म्हणजे काय? epsilon e म्हणजे d a इथं a d epsilon e by d. ठीक आहे ना? d by dt. बरोबर आहे? साधारणतः त्याच्या याच्याकडे येतात. मग एक अगदी ब्रॉड सांगतो, तुम्ही ते डेव्हलप करायचं आहे. So this leads to इतर गोष्टी कॉन्स्टंट ठेवायच्या म्हणून त्या बघायचा. So displacement current, how you get it to the final formula, it's you look out now, is equal to delta d by delta. Displacement current is delta d by delta t. So this is conduction current is J and delta d by delta t. These are two forms of current. Sorry, I made one small mistake. This is what? This is displacement current is sorry, just A doesn't disappear, is equal to A delta d by delta t. A is there. Now I divide this A, I take this on the left hand side. So when I take this A on the left hand side, what I get? So if displacement current upon A is equal to delta d by delta t. So this I can say as ZD is delta d by delta t. And normally you have got J as current density. So total current is total current density is J plus ZD, that is J plus delta d by delta t, which we had not taken into consideration in Ampere's law. So I will give further hint that the Maxwell's equation gets changed to del cross H is equal to J plus delta d by delta t. J plus delta d by delta t. And last Maxwell's equation, del cross E, what that would be? That is related to Faraday's law. So it is related to Faraday's law. What term should be there? Delta B by delta t term should come. That is the rate of change of magnetic flux, and when that area comes out, that is magnetic flux density. dA by dB by dA by d. I will complete this. So this is minus, why minus? Because length is small. So del dot d equal to rho v, del dot b equal to 0, del cross h equal to 0 plus dA by d by dA by t, and del cross is equal to minus dA by dA by t. These are 4 Maxwell's equations. Now, how do they get converted to vacuum? In vacuum, what will happen? These are the point forms. Integral forms you can derive later. In vacuum, what they will become? In vacuum there can't be conduction current. Conduction can't be there. So this becomes del cross H equal to dA by d by dA. Del cross E is equal to minus dA by d by dA. Del dot B equal to 0. Del dot D in vacuum what will happen? In vacuum, no charge can be there. This is like vacuum also. And now, if everything is time varying means D is said to be, everything is said to be having with frequency omega. So we have got a phasor concept in circuit theory. So with that phasor concept, each field is said to be harmonic. Sine you can consider, or e raised to also you can consider. So if D is equal to, what do they do? Then in book they write capital D. So bold D, but here there is a problem. So what I will write is, I will write with a different color. You will understand it better. You go through the book and then you understand. So what I make, D e raised to j omega. Each term B is equal to magnitude and then phasor, frequency. If everything is like this, what would be del cross H? What would be del cross E? So dA by d by dA by t, what that would be? It would, j omega will come into picture. J omega will come into picture. So I hope that you complete it by tomorrow. Hello.
नाही बंदच आहे आलो